I think that I think that I don't think that a whole bunch of things have changed with Red Hat 7. With regards to Red Hat 6. I think that a few things that have changed, well, changed really, really deeply. So, for instance, one of the things that changed was how the system, calls services. It changed from using Upstart or
Mm-hmm.
SysB, to using System D. That is a deep change. It's just one change, but it's a deep change. So all the ways that processes are being called have just completely changed. But that is all contained in this one chapter, right? That is all contained in this one chapter. It is not spread across the entire book. If you didn't know any Red Hat 7 coming into this, and this is why I like Red Hat versus Windows or anything, even when they make changes, the changes, you can relate to the changes if you knew an older version of Red Hat, you know. So the changes are, you know, are deep when it comes to, how System D calls services and changes run levels and stuff. Another change is with the file system, XFS. Red Hat 7 now uses XFS. Red
Okay.
Hat 6 used extension 4, for people who haven't had any knowledge of, of file systems. CK had a had a not so good experience yesterday. CK stumbled upon the bad sides of hard disks yesterday. What CK didn't know, he was texting me yesterday. What he didn't know was that at that same time at work, I was having issues with my hard disk. He didn't know that, and and it's it's really interesting. Um, so I think those are the two places that I really know that Red Hat 7 changed versus Red Hat 6. But there's nothing that a little bit of studying, a little bit of effort cannot change. You understand?
Mm-hmm.
You guys understand, right?
Yeah, we understand. No, I'm not disputing the fact that studying is not going to overcome the obstacle. I'm just stating that in chapter 7 alone, it's a lot of information, especially not saying it's my first time looking at it, but especially from the outside looking in when it's your first time tackling, through the jargon, the Linux jargon. So that's all I was saying. Like I haven't
It,
finished looking through chapter 7, but I
it,
know I have started.
it's CK's first time, and he's had an excellent time. I have been, you know, I'm using CK's book so I can see all his highlighted, all his notes.
Mm-hmm.
I'm pretty sure that it might have been challenging, but he went through it.
Of
He went
course.
through it. Anyway, so having said all of that, right? We know about run levels. They've changed to targets now. We know that
Mm-hmm.
the targets are, few and far between, but it essentially mirrors. I think the only thing you have to remember about the targets is that run levels 2, 3, and 4 are no longer run levels, and they've been
Mm-hmm.
changed, replaced by one single run level, which is the multi-user target. And that run level 7. I'm sorry, where did that come from? Run level 5. It's still essentially run level 5, right at 7, but it's called something different. It's called graphical targets.
Mm-hmm.
So I don't think it's much of a big deal. Okay, we talked about using single user mode. Oh, sorry, this is another thing that I know Siki asked questions about last week. Section 2.02, we talked about how to boot systems into different run levels manually, right? And and I said that you can boot the system into a different run level by catching it in the grub phase. Remember, when the grub shows up and it asks you what kernel you want to load, and you type in A, the letter A, append, right? And next thing you type in 1 or you type in S, and that puts you onto single user mode, right? We talk about that. Obviously, in the book, we learn about how you can, um, switch into a different run level while the system is running, right? Which is, or how to change even the default run level. If you guys went through the book, you must have seen that. There's a system control, isolate, default, right? Then you say multi-user targets. You say isolate default, Anyway, we talked about that. And I also showed you guys another shortcut because systemd is still accepting Red Hat 6 commands. You can do init 5, init 3, init 2, whatever, and you go to that different run level, right? So, I think we're all solid on sections 2.01 and sections 2.02, unless JP has any question.
No.
All right. So moving on, section 2.03. We talked about how to use single user mode to gain access to a system. Oh, we already mentioned that. We went through that. Section 2.04. Identify CPU memory intensive processes. This is extremely important. In Linux, it is extremely important to be able to know how to do this, right? But
what page are you on?
So I'm looking at the my objectives.
Okay.
I dropped it out.
Yeah, but that 2.04 is chapter 4. It's going to chapter 4.
Yeah, but I didn't even need to open it. So you went through it, right?
Okay.
So you guys remember I said that I did this syllabus with Red Hat 6.
Mm-hmm.
Obviously, in the Red Hat 7 book, we scattered all of these things in different places.
Mm-hmm.
So instead of being chapter 5, like I said in the syllabus, Seek is telling us it's chapter 4, right?
Mm-hmm.
Configure systems. Stop and check network service. Okay. Anyway, chapter 4. So who can tell me? Does anybody know how you can identify CPU/memory intensive processes? Does anybody know how to do that?
You can use like the top command or ps-ef.
Awesome. That's exactly what I wanted to hear. Okay, so I was battling with this all through this week at work. Maybe not all through the week. I have a co-worker. She's Indian, right? Not to say that she's challenging because she's Indian, but I just mentioned that this particular lady, she's an interesting person. She dreams up problems with her systems and she reports them to me. Now, my job is to make sure that all our systems are running smoothly, right? That is always my job. But this particular lady, she just comes up with these ideas. So, I think it was on Wednesday, she came up with a problem. She said that she couldn't run any of her jobs. We have a lot of jobs that run. We have simulations that we run. She said she couldn't run any of her simulations because her server was running really, really slow, right? So I wondered why her server was running really slow because I installed that particular server in December. It's shoulder now. That will not be hand now, shoulder. It was the shoulder. How can you not go with the shoulder? So I installed that I kickstarted that server in December. I know that in fact, it's one of our best servers, our development server. It's like a workstation. It had 16 gigabytes of RAM. The CPU was a virtualizable CPU. It was just awesome. She had like an Ivy Bridge processor. Like, her processor, her CPU was Ivy Bridge. So it's one of the Intel processors, one of the latest Intel. I think it was manufactured in 2012. So it's a pretty recent Intel processor. Intel processor, there's Intel Celeron, there's Intel, you don't want Celeron. There's Intel Xeon. Xeon is good. But these processors have different features. Some of them have features that they have like a 256 megabytes L3 cache. The L3 cache handles video processes, and instead of sending the video processes to your RAM, it handles it inside of the CPU. So the system is not sending too many messages anymore. It's doing more work inside of the CPU itself. Have you seen the motherboard of the system before?
Mm-hmm.
So if you see the motherboard of a system, you see that the CPU is one place, like a whole bank, and you see the RAM to the side. You see the PCI cards, you see the transformers, you see all kinds of things, right? But inside of that CPU, there is a RAM, there's a memory, random access memory on the CPU itself that you can use, that you can use to compute processes. Anyway, Ivy Bridge is one of the more recent ones. It's a processor that has that feature, and it's a really good processor. So I knew that this lady shouldn't have those problems, but I looked at her. I needed to troubleshoot the problem that she was experiencing, saying that this thing was running really, really slow. So I logged into her server, and the first thing I did, Chineke me! How can you miss that? I don't get it. Look at it. Look at it. Just look at this. So I logged in, and the first thing I did was I ran the top command, right?
Mm-hmm.
Top shows you the processes that you have run on your system.
Mm-hmm.
And it also shows you can, like I'm pressing the down arrow here. I'm pressing the down arrow to look at all the bottom ones, the ones at the bottom, to see all the processes at the bottom. See, there are how many processes? There are whatever. I don't think there are numbers serially. But there are these processes, and you can see the PIDs. These are the PIDs. This is the user that is running that process. And this is the priority. This particular column is the priority. And this other column is the niceness of that particular process. And this column tells us the virtual memory that it's using. And this one tells us I think it's the reserved memory. I don't remember what resources that it's using. I don't remember exactly what it means. You guys can read about TOP and find out all of those things. I don't remember what this and this stand for. Then it tells you the percentage of the CPU that is using, that particular process, the percentage of the CPU that is using. It tells you the percentage of the RAM. Percentage of the RAM, percentage of the memory that is using. It tells you how long that process has been in effect. In hours, minutes is the middle one, and in seconds, right? And it tells you what command it was that started that particular process. Okay, so that's a brief overview of what TOP is. Everything on here, everything on top here, is essentially just, a summary of what is going on in your server. Okay. Anyway, you can invoke the TOP command by just typing TOP, right? You just type TOP, it executes the TOP command. Now, there's also and for you to exit the TOP command, just type the letter Q, right? Just type in Q. Now, there's also another one called HTOP. I like HTOP better. It doesn't come by default to Red Hat 7, but I like to install it on my servers. I installed it on this particular server, because HTOP gives you much more. It's much more interactive, really. You can select a particular process on HTOP. You can select the process. No matter okay. You can select a process, and you can go through and select the process. There's a lot you can do. You guys figure it out. HTOP. I like HTOP a whole lot better. Okay. So obviously, HTOP means humanly readable top, whatever. In Linux, when they realize that they've done so much to benefit the coder, they go ahead and they do a more interactive version, and they put an H to it. or they say that you can run the command and say -h. For instance, df-h, right? CK was asking me a question during the week. He was like, what is df? If you run df as a command, it just shows you this. You don't know if this means. Are you looking at my screen? I'm not looking at my screen. Look at my screen. Your laptop, I need to throw them away. Sensitive gains. The wires are touching. But when you do a df -h, it starts to print out. I mean, I don't know what this means. What does that mean? Is that in kilobytes? Is that in bytes? Is that in megabytes? It says 1,824. I'm sorry. 1,824,836. I don't know what that means, right? But if you do a df -h, to press it out in human readable format and tells you it just means 1.8 gigabytes. I see 57,492. I don't know what that means. Is that in kilobytes? Is that in bytes? Is that in megabytes? But if you do a -h, like here, it tells you this is a disk usage statistics. In megabytes, it just means 57 megabytes is being used. Okay, so anyway, that's essentially what htop does. htop prints out your virtual memory statistics and your memory statistics in human readable format, and you can go through and select what particular service that you want in the PID. You can go through it and stuff. Anyway, so our task today is to learn how to, like your syllabus will say, how to identify CPU memory intensive processes, right? So when you look at htop, or for that matter, when you look at top, the top, the reason it is actually called top is to tell you the top memory intensive, CPU intensive, resource intensive processes. Right? That's why the command is called top. That's why the utility is called top. So it shows you the top ones first, the ones that are using more resources first than anything else. Right? Let me switch over again to my code. When I look at our system, I noticed that there was a particular process that was using one process only. One single threaded process was using 100% of our CPU. 100% of our CPU. The other time that I've seen that is when I was working with the US government. And somebody was running a job, and this was in our high performance cluster. And because in that particular job, the person was running had a memory leak, and he was using up 99% of the CPU. How can you use 99% of a 256 core? 256 cores. So each CPU is one core. Each CPU is one core, right? But because of the way that we grouped our high performance cluster, there were 256 cores of CPU. I don't know if there was 256 servers. It might have been that we had a CPU, we had a server that had 4 cores, or maybe 8 cores, or 16 cores. But this was 256 cores. And this person was using 99% of those cores. Just grinding every other process to a halt. Nobody else could run any other job except that particular user. Right? That's the only time I have seen anything like that. So I started to wonder why this my coworker, that one process was using up 100% of our CPU. So I started troubleshooting. And that's what this chapter is about. This particular segment is about to introduce us into the concept of troubleshooting. What do you do when you want to troubleshoot? I've already done the first step of troubleshooting. Somebody called me and told me my server is running slow. I can't compute processes as quickly as I used to. I've been using this particular machine for 3 months now. I don't know why it's unduly slow today. This particular day, what is going on? What is wrong? And you need to understand that when I'm going to call her customer in this case. She was not a customer, but when she's my coworker. When these people come to you, they are panicking, they are unhappy, they are uncomfortable. They feel that you have done something to break the system, right? So you need to assure them that you are working on it and that you're going to get it resolved as quickly as possible, right? So she came to me, she was like, she didn't even come to me. She went to my supervisor. Her processes are running really, really slow. She doesn't know why. That since we moved into this building, it looked like something has changed. Who was in charge of moving us into a new building? It was me, right? So if she's saying that something has changed, that means I changed something or I broke something and I didn't tell anybody and I haven't fixed it yet. So she was reporting me to my supervisor. So I walked over to her and I asked her, what's going on? What's happening? She was like, well, this is this, that. I was like, well, you could have told me. You could have just walked over to my office and told me what you were experiencing. I'll look into it, right? She was like, yeah, but then she's just frustrated that she's sorry. She should have told me, but she's just frustrated. Anyway, so the first thing I did was to run the top command. Because when somebody tells you the system is running slow, 90% of the time, their memory is small. 90% of the time, they've used up much of their memory. 90%. Hardly would you find a situation where somebody has used 100% of their CPU. It doesn't always happen. Like I told you, in my entire career, I've only seen it one other time, and it was 99%. It wasn't 100%. But in this particular case, she reported that everything was gone. Everything was ground to a halt. Right? So I started to look into it. JP, are you following?
Yeah, I'm here.
Okay. So the first thing I did was to run top. And when I looked at top, I saw that it was just that one service that was running, using up 100% of the memory. So I asked her, what is that process? She told me that that's the normal job. That's the same job that she runs every other time. And that if she runs it before, it probably uses up 5% of the memory. 5% of the CPU. So what I did next was to try to figure out why that particular process was using up, 100% of her CPU. And what was the next thing that I did? Next thing I did was I decided to do this. Everybody look at my screen. I decided to do this till 1,000 varlog messages. That's what I did. We haven't gotten to how to interpret log files. I don't know if it's in this particular. Is it? Awesome. So I'm going to teach all of this at the same time. It's actually 2.05 on our syllabus. So I looked at this particular log file. This particular log file is called varlog messages. Everything that happens on the system is logged into this particular one file, the messages file. It's located in a subdirectory called log, and that log directory is located in var. All of us know why var is called var, right? Because it's variable. It is a file directory. It's a directory that changes in size. Why does it change in size? Because the system is keeping a log of everything that happens in there. And those logs are constantly growing, even when you think that the system is not being used. Those log files are constantly increasing. There are many, many log files in there, including messages, right? And they're always changing. They're keeping it up. Every time you log into this server, I know that you logged in because it's logged into the varlog secure. It's a file called secure, but it's located in the log subdirectory, which is located in var directory. Okay? So I looked at this and I started to scroll through what was going wrong with our system. I was scrolling through. I couldn't see anything that was happening. I was scroll through. I couldn't see anything that was giving me any error. I couldn't see any error messages. So I decided, okay, that what will happen is, instead of tailing the log file, JP, do you know what tel means? When I said tel 1000, what does that? When I said tel 1000 valid messages, can you tell me what I mean by that command?
Yeah, it means the last 1,000 commands that were
No,
received.
not commands. Replace commands with something else.
Uh,
You are very close, very, very close, extremely close. If I'm telling a file, I'm looking at last 1,000 words of that particular file, not commands. A file doesn't, so a log file doesn't contain commands. It contains.
It's logs, entries.
Okay. Yeah, give me 1 second. Mrs. Good morning. Ma? My sister. Oh, long story. I'm not going to be able to play that role. I'm sorry. I'm not going to be able to do it. Eh? I don't know. Anyway, I'm not even going to be able. I'm not going to be able to make it on time for the meeting because I teach a class every Saturdays, and my class today ends at 1. So Tiki can play that role. Are you serious? Oh my goodness. Whoa, my dear. So I'm in the middle of class. I'm in the middle of teaching a class, and I probably need to call you back. But I don't think I'm gonna. If the meeting still holds at 11, I'm not gonna be there. I mean, I explained this to Bro Finisher before I joined the group. I told him it would be tough for me to make Saturday meetings unless they come in, unless the meeting is hold after 1, or maybe after 12. You know. Yeah. Okay. Okay. I'll send you a message. Thank you. My dear. We'll talk about it later when I see you. Yes, I'm definitely coming today. I'm definitely coming today. No doubt. Church is 2, right? Yeah, I'm gonna make it to church. I'm bringing my whole crew. Oh yeah, okay. Yeah, that will help me out a whole lot. Yeah, if you can do the reception if you can do rehearsals at the reception, then that's fine. Mm, mm, okay. Okay. Awesome. Okay. Yeah, yeah, we do. Yeah, I have an idea. I don't know. Well, I'll do my best. All right. See you later. All right. Bye. JP, have you had the time to think about it?
I think I already had the answer from Crystal.
I
So
didn't hear what.
the
I want.
last 1,000, the thing that will be in there is either the entries or the logs. Is that correct?
The last 1,000 entries, which is the last 1,000 lines. The last 1,000 lines of
Nice.
the message.
Okay.
Okay, the last 1,000 lines. If I
Yeah.
do, remember I told you guys to read up this thing in chapter 1. Can you guys just take him to the room? Because I want to keep music class. So when you do a head, and CK actually answered this question more or less in that particular class that I taught when we were in chapter 1. When you do head -5, you're printing out the first 5 lines. This is line number 1. This is line number 2. It always starts by the date, the time. Line number 3. This is line number 4. This is line number 5. The same principle works when you say tail -5. You're essentially saying, show me the last 5 lines. Last 5 lines of that particular file. It's going to show you 1, 2, 3, 4, and 5. You shouldn't make this thing hard for me. Okay? So I decided to print out the last 1,000 lines of this lady's messages log entry. Okay?
Yeah.
And I wasn't satisfied with that. Now, there's also another command that you can use, especially when I typically use this when I say telf. When I telf a particular file, what I want Linux to do is to show me a frequently updating running of that particular log file. Telf, var log messages. Look at the command here. Right? I'm telfing it. But it's gonna, you see where the prompt is? The prompt is waiting for me to, if anything else happens on the system, like if CK logs up now, CK, try and open a new prompt, open a new PuTTY session. Just right click over PuTTY. There you go. No. Right click over PuTTY. Right click. There you go. And okay, I'll just say PuTTY. Okay, let's use Alpha. Double click Alpha. So as soon as CK logs in, you see the log just changed. You see my telf. It just said Alpha Red Hat System D started session 1428 of user Kingsley. System D login D. New session 1428 of user Kingsley. Starting session 1428 of user Kingsley. So when you do a telf, it's just going to open up that particular file and constantly update you with the output of that file continuously on that particular server, on your bash screen, on your monitor, right? Anyway, I needed to
So it's more real time.
yes, you want to see it just happening. Anyway, so what I did was when I did that particular, I did 1,000, and I wasn't happy with what I was seeing. I tried to dig in a little bit deeper. Now, this whole time, all I'm doing is troubleshooting this woman's machine to figure out what happened. So I decided to VIM that particular file. VIM will open up the entire file. Remember, we've used tail to look at the last 1,000 entries, but I'm thinking that this particular problem might have started a long time ago and nobody has solved it. Right? And there have been more than 1,000 entries that happened. So I said to VIM the file, to VIM that particular file. So I opened the entire file for reading. And I'm scrolling through from the head of the file. Obviously, with VM you can do page down. You can press the page down button on your display and you see page down. If you look at this bottom corner, it will show you 1% of the file. It's seen 1% of the file. It will show you line this. This is the line statistics. We are line 92 of this particular file. We've only read line 92. We'll keep updating. And updating line 129, line 155, whatever. And it's only showing us 2% of that particular. So this is a huge file. We've looked at 240 something lines and we're still at 3% of the file. Right? So I was looking at it, and at some point I came to the point where I found out that something had happened to the woman's system. And there was one particular service. There was a particular service called Tracker Store, right? Tracker Store is an indexing service. It's not even on here because we don't have the GUI version of Red Hat on this my installation. But Tracker Store is an indexing service. If you have a GUI version of Red Hat 7, right? Okay, so you know the GUI only runs on what targets? Exactly. You know, graphical target. You know, the GUI only runs on the graphical target. If you have a GUI version, if you have a desktop version of Red Hat installed in your system, and you're on a graphical target, then there's a score there. You know, so you know, when you log in, there's a search bar there that you can just type in any search. The way that search bar works is because the system goes in and it indexes all of the files in a particular service that is called Tracker Store. Where? Who be this fucker? Hi. No, just say one la. Brought in fucker. Compato. Dear. I want us to lose this game. I want us to be Brazilian's first loss. Anyway, sorry guys. So Tracker Store is a service that indexes all of your files, creates a database, updates that database with all the files I have in your system, right? That's what it does. It's only available on the GUI version of Linux. If you install the desktop version, that's when you get that Tracker Store. I knew that I had seen that before on one of my coworkers' systems. And every time Tracker Store runs, it just completely just kills, it just ties a rope around the neck of your server. It ties it now. You won't tie a rope around the neck of your server now because you're not doing a lot. You don't have a lot of files. But at my job, our simulation opens up more than 1 million files. One simulation that we run is essentially reading the contents of over 1 million files. It's pulling information from a whole bunch of files that we create, different scripts, thousands of scripts out there. So what is happening is that Tracker Store, every time that lady is running that simulation, right? Tracker Store is instantly trying to index all of those 1 million files that are being opened, right? So the CPU is just doing a lot of work, which is making the system run slow. That is the long and short of my troubleshooting, right? As soon as I figured that out, I was not trying to find out how to disable Tracker Store, how to remove it without destroying the system. How do I render this particular service inoperable so that this my coworker can run her jobs, right? That's what I was not thinking about. Anyway, but keep in mind, the first thing that I did was to run top. I ran top. I ran the top command and I looked at how much memory was being used. And the system told me that there were, even the Tracker Store wasn't using a lot of memory, but it was using a lot of CPU because it was too much computation that I had to do. Tracker Store was going back and forth to the CPU, telling the CPU, I have found this particular file. The file name is this. It is located at this particular place. This is the absolute path to that file. And you store it in the CPU's temporary memory. Then from the CPU's temporary memory, you will move it to the RAM. From the RAM, you will now move it into another memory altogether. Right? This was what was constantly happening for 1 million files. 1 million of them. That was why the CPUs were so busy. So that meant that the CPU didn't have enough time to now do the main job that it wanted to do, which was computing the simulation, accessing the files itself. It was now slow. It had to handle Tracker Store first. Right? That was a problem. So I ran top and I found out about that. Top displays your memory, it displays for your system a lot of things. It shows you the process ID number of that particular process. It tells you what user is running that particular process. It tells you the priority of that particular process. It tells you the niceness of that particular process. We're going to go through all of this. It tells you the virtual memory statistics. It tells you the result. I don't know what this is. Well, you guys, that's your job. Figure out this three columns. CPU, percentage of CPU, percentage of RAM. Okay? There is also another tool to use to find out how much memory the system is using. Does anybody know?
Peace. Start.
Okay. Start.
Start dash V. Dash V.
Is this
How
start?
about just start? Just start.
Start shows you information for a particular file.
Uh,
Do you know?
What's the question?
Do you know any other tool that you can use to figure out the memory statistics?
Process.
You can use VMstat. Is that? You can use IOStat.
Okay.
I already said PS-EF. I already said TOPS. Yeah, those are the only ones I know. There may be more.
I don't know if IOStat is deprecated in here.
Is the okay?
But I know about IOStat. So IOStat doesn't give you memory statistics. It has the CPU statistics.
Okay.
IO is anytime you hear IO is about the CPU.
CPU. Okay.
Yeah. So yeah, but VMstat is definitely a valid tool that you can use to check memory statistics. But it only shows you the virtual memory statistics. It doesn't show you other memory on the system.
Okay.
It shows you swap. It shows you
Okay.
statistics. It tells you the free virtual memory. It tells you the buffer. It tells you the cache memory, and all these other guys. Yeah, I was going to get to that.
Okay.
So there is also, you guys remember when we talked about the system directory, right? Remember when we talked about the root directory? I just feed it into root now. I'm inside the root directory. And we talked about all of these things, and I mentioned to you guys that bin was where you store many of the system binaries. Most of the system commands are going to be stored in here. Boot is where you store the boot information for the system. Data, all of these things, etc., is the configuration files for the system. All of our home directories are stored under /home. But I also talked about proc, if you guys remember.
Proc. I said processes. Didn't you hear me?
Okay. What did you say about?
I said you were asking for commands to see, how a system is being run. Like a minute ago, I said processes.
Okay.
Yes, and I said processes because I recalled that I recall that we've mentioned that word before in part of this our classes, and yeah, I recall that. Yeah, processes. Yep.
So
I did that.
when we see the into proc, right?
Mm-hmm.
By LL, we find a lot of files and subdirectories. Now, the proc directory is a special directory. It stores a lot of all the directories inside /proc are. Christy, you can see VM stats, right? Uptime, you can see version. All of these files, even swap, these files don't really exist. These files are not physical files. These files, you can see the size of these files are what? 0, 0, 0, 0, 0, 0, 0, all of them 0, 0, 0, 0, 0, 0. Because these files are virtual files. They all handle information that is removed. That information is completely lost when you restart the system. The information inside these files are completely lost when the system is rebooted. Does that make any sense? /proc stores temporary file information, essentially. Now, I like to do this. I try to do cat proc. Inside of proc, there is a file called meminfo, right? Memory info, memory information. If I go into cat proc, if I say cat proc meminfo, it will show me all the information about the memory on the system, right? But keep in mind, meminfo as a file, remember it's stored under /proc. So it's all the information in this particular file is lost when I reboot the system. When I reboot it, it boots up with new information, essentially. This file just updates virtually. When the system is on, it just updates virtually. It doesn't write anything hard into the files. So I see that memtotal. I see that the total memory on my system is 1,000. I'm sorry, 1,015,472 kilobytes, which is not much. Which is just 1 gigabyte of memory, 1.5 gigabytes of RAM. And this is my server. See how everybody logs into this server. All of you guys do your, processes, all of you guys do your stuff, but it's only just about 1.5 gigabytes that is on this particular server. And of that 1.5 gigabytes, I'm using up about 6 megabytes, leaving just about 9 megabytes. Right? So this is what happens this is what you see when you cut, proc meminfo. You can also see the swap cache, 0 kilobytes, active, whatever. All of this Google to go here. It doesn't even I don't have a swap file on this particular server. Typically you have a swap file that is at least 2 times the size of your RAM. So a swap file is like a secondary RAM. So that's one of the advantages of Linux. You can create a space on the hard disk where the system can use as swap. Have you ever plugged your flash drive into your Windows machine and it tells you use this hard drive to speed up your system? Have you ever done that? And if you click it and it's going to format it and it's going to chineke. Abysmally poor. So what that really means is that on your hard disk, Linux can, if I find out is plain 9, see, hi, just voila. I want this to be Guzerink's first loss. I want it to be his first loss. I want it to be his first loss. I don't want just to stop. I only want us to just off go kick. Sorry about that, guys. So you can create a swap file and you help your system's RAM. If your system had that, like this one particular one needs a swap. I can show you how to do it eventually. Use the dd command to convert part of the hard disk into a swap file. So you need to know how much hard disk you have. In this particular case, I have 10 gigabytes of hard disk space. I have 8.3 available. I can take 2 gigs and make it into a swap. I'll just do a dd if and say dev x vba to Anyway, we'll work on that later. I'll show you how to do it. You can create a swap file from this. So, but when you cut the proc file, you can see all the information about the system memory, not just the memory, but also the swap and other stuff. Go kick. You see all that information. What I typically do is I say proc mem info, and I go man total. I know there's a segment of that shows me the total memory on this system. I think I've tried -H before and it works, and it told me. Anyway.
Newcastle is going down.
Huh? When I do mem total, I'm only grabbing. This is the cat proc mem info command, and look at all this things. I know that there is a part of it. There is something here that shows me the total memory on the system, and it's called mem total, right here. So if I log into your server and you're telling me you're having problems, instead of me going through a lot of things, I just go, let's do grep mem total. Tell me the total memory on the system, and it prints it out for me. I grab for it and I print it out, right? That's what I do. That's what I typically do. Okay. So, much Angola. I like the test semester this and I hope we lose to Man City next weekend. I'm gonna watch the game live. London League is falling down. Jefferson Montero, Columbia, and brothers. Anyway, so I use this particular command, cat proc mem info, to find the memory statistics of a Linux system, right? I also use another command. This is the one that you guys might remember easily. Free -H.
Yep, you're right. I forgot about that.
So free -H will tell you the total memory. See, it tells about memory, it tells about swap. The next, so this is column, this is cell, right? No, not cell. Column, column is done in Excel again. Column is the vertical ones. What are the horizontal ones? Horizontal row. Thank you. So this row talks about the swap. This particular row talks about the memory of the system. Tells me that I have 991 megabytes of RAM total on the system, and I've used 103 megabytes of RAM, and that I have 884 megabytes free, right? Which was what we saw that when we did. We also saw that when we did VM start, right? Shows that this is what's free, which is about 87 megabytes of RAM. So that prints out that information. The next information that I really want us to go quickly, because I've spent too much time on this, the things that you guys are going to be able to read quickly, is CPU info, which was where Crystal came up with IOStat. If you don't want to know what happened, just put your phone on silent. You don't want to know what happened on ESPN and stuff. Save us all those notifications. I'm not interested.
Chelsea lost. So.
I watched it again. What do you mean?
I need to reinforce it.
Am I a Chelsea fan? What do you do? What are you doing that for? Unless it's CK. Well, CK has a reason not to be able to, not to be your friend anymore. Not like close.
I need to reinforce it. Don't be all slick. You have always identified with Chelsea, so I don't know this hubris.
How is
What
this?
is? I don't know what this hubris is for. You've always identified with Chelsea.
This is not hubris. What do you mean? I don't know what package this IOStat comes in.
You can try LSP.
LSCP is also there are plenty of them. I'm going to go to all of them. Oh man. Messed up.
Hello? Yeah.
Stat. I made a mistake. So my H stop just updated. KRB file. Open up now. So the package is versus system per statistic. What do you mean it's not available? Okay, I made a mistake. IOStat is not used for CPU information. It is used to check the read-write I/O of the hard disk. That's what it printed out for me here. I realized that when I was about to install it. Okay, so it's going to show you the read-write statistics, how your CPU is able to read and write to the hard disk. That's what IOStat does. Sorry about that, guys. Okay, so to check CPU, top also, you can also use top and check this column to see what is using right here. Anything under this column will show, like now Kingston is using 0.35 percentage of our CPU by him doing an H stop, right? You know, oh, okay, but you can also use another command called cat. Are you paying attention?
Hello?
I'm asking you a question.
I'm here. Sorry about that.
Are you done with your call?
Yeah.
I was saying that same POC subdirectory. You can also, there's also another file in there called CPU info that will tell you everything about the CPU. If you care about
Okay.
POC CPU info, it tell you how many processors do you have. It says 0. Amazon is really, obviously the reason that they're saying 0 is because there is no particular CPU that is devoted to this. This is a cluster. It says genuine Intel processor and it gives us a generic name. This is the Intel sign I was telling you guys about. It's a good one. That was siblings. You print out the CPU information, right? So this will give you an overview of what processors they are using. You know, LS CPU. CPU gives us just about the same thing. So Little Indian, you guys don't know what this is. I didn't know what this was until I started working for Boeing. You know, they use Little Indian architecture, and I don't want to confuse anybody. It was even confusing to me. I was there, everybody. You know. Okay, but it usually tells you all the information about CPU. It tells you online CPU list 0. How many threads per core? It says 1. Core per socket, it says 1. Sockets 1. What this is telling me is that there is no single CPU that is assigned to our server, right? This particular server is in a high performance computing environment where there are multiple servers all grouped into one. And anytime we log into this particular server, we can just use up anything that we see. It could be multiple CPUs working at the same time. It could be one CPU working at the same time. But it's just assigning us the equivalent of one CPU. It doesn't know the name of it, right? So that's what it's showing us here. Remember when I talked about L3 cache? This L3 cache is a space on the CPU that is like a RAM. You know, the server can use it to process, the CPU can use it to process, processes that need a higher priority. We're going to get to priority next. That's the next thing we're going to be talking about. So I only have 2.5 megabytes of 256 megabytes of L3 cache, which is pretty standard, which is pretty common. For more beefier, systems, you probably have like 2 gigabytes of L3 cache. The system is going to be incredibly fast, So that's what that shows us, But again, we go back to top. Top gives us a whole bunch of the information. If there was something that was bugging down our CPU, we'll see it here. If there was something that was bugging down our RAM, we'll see it here. Okay? Any questions? No. Any questions?
Just a quick question, and I want to know the difference from the command find and grep. Do they perform exactly the same thing or similar or not?
It's in your book.
Okay.
It's in chapter 1. I'm not going to answer that question because we're supposed to read it out by ourselves.
Carry on.
So, so on our syllabus, the next thing is, memory intensive processing. We already learned that adjust process priority, release, and queue processing. So I have taught this particular release before, but I've never used it at work before, ever. I've never had to use it, right? The chances of you guys using release to adjust the process is very remote, right? Because typically Linux, what it talks about, what Linux means is, when it says adjusting a system priority, right, is, remember when we did top, and I told you guys that this particular part is the priority of that particular service, that particular process. So what happens in Linux is that every process in Linux goes from minus 20 to plus 20 in priority. Minus 20 meaning that that is the most important, and 20 meaning that is the least important, right? So if your system is running normally, everything is probably going to just be 20, 20, 20, 20. You're not saying that you want something to be more important than the other, all right? But when you now start to have computations that are heavy, and you want the system to be able to, assign a particular priority to a particular service, then you want to tell Linux to do that. You want to either give you the process ID number and tell it what priority that you want it to be, right? So that my coworker that was having that problem with her simulation, I could have told Linux that I want process ID number 1577, which is her simulation. I want it the priority to increase to -20, which means leave everything else and run that job, right? And Linux won't bother sending any other information to the CPU to process, apart from that particular one service that I want you to run. Apart from that particular one, right? So but in that particular case, I don't see how Renis would have helped us, because I knew at that time that even though her simulation was running slowly, there was another particular service that was tapping onto that simulation and making things run ever more slowly. And even if I gave her process, even if I gave that simulation priority, she would have still been running slow, because Tracker Store would have still been indexing the files. The only thing that happened was that the files, the simulation would have been running, trying harder to be able to reach those files. But Tracker Store would also be working slightly even harder to be able to index those files. So I knew that Renis wasn't going to help me. I've also worked in a high performance environment where we had 50, maybe 500 scientists submitting jobs. All of them they're bringing in jobs every single time. You can give each of those jobs priority and say, this is what I want you to run. I want you to even use 100 CPUs to run this particular job. I want you to use 300 gigabytes of RAM to run this particular job. I want you to run this job in 3 months. You could block off that particular part of the resources and use it to run that particular job. So because of that, I never needed to use Renis, because Renis only adjusts the priority. But I could use another tool on my high performance cluster to adjust a particular job, to use any particular resources that I wanted. All right? So I've never used it before. I've never used Renis. I just know it in theory, that this is how it's used. I just know that in theory. Where is it? Niceness -2 top. So for practical purposes, the way that I know, I don't even have anything running here. So I can change the niceness. I can say adjust the default niceness of the system is 0, which is, I can say, from according to the book on chapter 4, page 109, I can say nice-2 and I say top. Right? Where is it? CK. I press Q. Let me see. It's a Q top. H top. Stop. Let me see this top again. Just press Q. It's what I asked you to do. Why am I not saying So remember I told you guys that HTOP is really nice. You can do stuff like that, right? You can also just click it and it will respond. I was able to tell the niceness of HTOP was too. Like I was flexing, you know. You can also do now. So Renis, nice. Renis, nice. To just help you change the priority of the process. You guys read that up. I don't need it. I've never used it. If you want to use the theory, that's all fine. I need to teach more important things than that. PS command. I don't know any command that is as important as PS in Linux. I don't know anyone. No other command. Right? If you do a PS-EF, right? It shows you everything that is running on the system. It shows you the process ID numbers, which is the PID, right here. And shows you who is running them. You can just go in and kill that particular process. Right? So there are many, many options to using PS as a command. I've already given you guys PS-EF. I also like to use PS-AUX. It shows you just about the same thing. There are many, many combinations of it. I also like to use PS-AXJF. This one is interesting. I like it. I like it because it draws like a spider web for me. It tells me one particular user logged in, and this is what this user is doing right now. So in this case, it says SSHD, EC2 user, that's me. That was me, I logged in and I executed bash. And I did sudo su, which was when I switched over to root. I switched over to root, and it put me on a prompt called bash. I'm going to be telling you but it tells PS space, no dash, AXJF. J as in Jesus. It says, SSHD. Crystal executed the SSHD command, and she authenticated using her private keys, and she came in, and she's now Crystal at PTS whatever, and she's on the bash screen. It tells me about Kingsley. It tells me Kingsley is here. Kingsley yada yada yada. JP is not logged on. How do I know that? Because PS told me. JP is not logged on. See? John Paul.
Yeah.
Is there a reason why you're not logged on to our server?
No particular reason. I've been engrossed with the classes today.
Engrossed? Oh wow. Okay. So that's what you do with PS. So for instance, when you find out a particular process, I can log all of you guys out right now. Everybody can log everybody out right now because I know the PID numbers. Right? I can say when I did the PS-EF or PS-AXJF and I found out that Crystal is using this particular PID number, I can just say kill 1149/9 is not something that I use often. If I run the W command again, Crystal is no longer logged in. Meanwhile, Crystal was logged in a second ago. Right? I just killed Crystal. Just logged her off. Kingsley is logged on twice. Obviously, the one you logged in at home and the one that you're logged in now. You never signed out at home, so I don't know which particular process is current. See the one that you're idle. You've been idle for 40 minutes and 51 seconds. 40 minutes and 51 seconds. Let me see if I can figure that out here. Kingsley 1, Kingsley 2. I think it might be this one, 1007. Yeah, 15999. So if I do a kill 1599, Kingsley is going to be logged off at home. But it's still logged out now. I killed his particular session before. So Kingsley is only logged on once now. Okay? So that's what you can use PS for. You can use PS-EF and grep. Grep for a particular service. Is Apache running? If I wanted to know if Apache is running, I'll do this. And I'll say that, oh, Apache is running. This is the process ID number for the Apache. Right? And I can kill it. I can kill it knowing this. Right? If you have problems in your system, you can use PS to fix that pretty quickly. Okay? Are there any questions?
No.
So section 2.05, locate and interpret system log files. Let me go in there quickly. You guys have a lot of work on your hands. Now, as a programming note, I'm not going to be in class for the next 2 Saturdays. My wife and I are traveling out of the country. We're going to Europe. So even as much as I don't want to miss classes, I don't want to have any break in classes, you guys can be sure that I'm going to give you a lot of homework. I'm going to give you a lot of things to keep you guys busy. And when I come back, we'll continue from where we start. In fact, I'm going to let you guys handle, let me see. I'm going to let you guys handle.
I'll be traveling too.
How convenient. How convenient. Crystal, it's not June yet. You typically travel in June.
Why do you know my travel schedule? Whatever.
I've been knowing you for years, Crystal.
I know. I'll be traveling next week.
Where are you going at?
Trinidad and Tobago.
Dang. How many times have you been to TNT, Crystal?
I haven't been to TNT before. Biko, please stop.
Well, you've been to a whole bunch of Caribbean places.
Oh my God! My mama won't let me go to Europe because it's too much hostility. If I had my choice, I would go to Paris or Italy.
So we have a 12-minute break right now. We're going to resume at 11:30, 12:30 Eastern Time, so we can talk about all the travel elements within that period. That's good. To 12, right?
Okay.
Yeah, so I'm going to be away for 2 Saturdays, all over Europe.
What part are you going?
I'm going everywhere. I'm going to, hold on, let me stop. Let me stop.